think we're all set to get the meeting started. So take it away, Chris, with the sky this month.
Thanks very much, Paul, and hi, everybody. So I'm going to cover the sky this month, coming to you from beautiful Thornhill, Ontario. So I'm kind of just down the road a little bit from Paul, and I'm not far from the David Dunlap Observatory, just next door in Richmond Hill. So I'm going to cover the sky this month from September 8th tonight to the next RAN meeting on October 6th. And let's get started. I'd like to acknowledge that I'm going to use a few members' images in my talk. So I've got a few names here listed that are people that have contributed some beautiful pictures to the presentation. So just to start out with a little bit of news on space exploration, of course, all kinds of countries are getting into the space game now. Lots of launches, lots of satellite constellations being launched. But so, it's not such, appointment TV or appointment internet to log in and watch the launches. But there are a few really interesting ones that are coming up in the next month, and they involve human beings. So we've got on September 15th, time to be determined, SpaceX is going to launch their Crew Capsule Crew Dragon mission with the Inspiration 4 mission crew on board. That's in support of St. Jude's Children's Research Hospital. And that's partly funded by billionaire Jacek Isaacman, scientist and educator Sean Proctor, medical officer Haley Arsenault, and mission specialist Chris Sombrowski. So keep a lookout for that. Then on October 5th, we have a Soyuz rocket lifting off from the Baikonur Cosmodrome, and it's delivering crew to the International Space Station. And this one's interesting. It's got cosmonaut Shklaparov, Anton Shklaparov, film director Klim Shipenko, and actress Yulia Perisil. That's them pictured in the picture I'm showing here now. So they're going to do some filming for a movie, an upcoming movie at the International Space Station. And then also in October, yet to be determined or pinned down, the Chinese are going to launch their Long March 2F rocket from Jiuquan, China, and they're delivering 3 Chinese cosmonauts to dock and rendezvous with China's Tiangong space station in low Earth orbit. So lots of fun there. Getting into observing, this is the window is now open for seeing the Zodiacal Light in the pre-dawn sky. If you're lucky enough to live where there's no light pollution and you've got a nice dark sky, you can pick up this subtle glow of interplanetary dust sort of sprinkled along the plane of our solar system. This is a gorgeous picture taken by Stu McNair on a morning in October of 2018. And you can see that this glow is kind of coming up diagonally. What this is that at this time of the year, the ecliptic in the morning is rather vertical where it meets the horizon. And that lets the sun set rather low, further low, below the horizon, and allow this interplanetary dust particles to scatter the sunlight and be visible just above the horizon for about a half an hour, 40 minutes before the dawn starts to brighten the sky. If you're going to get out and look, you can see the Zodiacal Light between now and about the full moon on September 20th. And the place to look will be basically below, in the constellation of Cancer, but below Castor and Pollux, the bright stars, and to the left of Procyon. So you can pick that up. Don't mistake it, though, or don't confuse it with the Milky Way, which will be rising also vertically from the horizon, but a little bit to the other side. Oh, by the way, another window of opportunity for that opens up on October 5th. So if you miss it this time, you can catch it the next month around. Don't forget the sun. So after quite a few years of quietude, this solar cycle 25 is just getting underway, and we've already been seeing a number of sunspots on a pretty regular basis. So those are great to observe if you've got a safely filtered telescope, or you make a pinhole projector, or grab those eclipse glasses that you may have kept from a previous visit to the Science Center's solar viewing day, and check them out. If the spots get large enough, then it's possible to see them with eclipse glasses without magnification. Of course, if you're wanting to use binoculars or telescope, you must have proper filters that'll keep your eyes safe. If you're curious about whether there are any spots on the sun right now, click on over to spaceweather.com, and on the left-hand side of their webpage, you'll see a small thumbnail of the sun. If you click that, it'll grow enlarge, and you'll get a picture like this that I'm showing on the background. And this is showing basically yesterday's sun and several major sunspot groups that are visible right now. The sun rotates about once a month, so every day these spots will migrate a little bit across the sun's surface. So typically you've got 5 days or a little bit longer, 5 days to 7 days to see the spots when they appear from one edge and cross the sun to the other side. If you're interested in helping to track the impact of light pollution in our skies, you can participate by joining the globeatnight.org campaigns, which have folks go outside, look up during particular weeks of the month and see how faint the stars you can see from your location, and then log in and report your observations. And the September focus is the constellation of Pegasus, and they provide you with a set of charts with varying degrees of light pollution. So if you're lucky enough to live in a magnitude 7 sky, then we're all going to find out where you are and come visit. But most of us are in these more limited star skies. So you see what you see with your own eyes, log in and let them know. And that helps produce maps of light pollution and track its changes over time. Here's the website, globeatnight.org. And I've circled the next campaign is between September 27th and October 6th, looking at Pegasus. In terms of sunrise and sunset, so obviously we're getting into that time of the year where the sunsets are arriving earlier. Tonight's sunset is at 7:39, and sunrise will be tomorrow morning around 6:50, which gives us a day length of about 13 hours, just under 13 hours. By the time of our next RAND meeting, though, the sunsets will be arriving nearly an hour earlier, and we'll have actually reduced our daylight hours by about 90 minutes. So we're going to get more night, less day. And in the interim, we've got the northern autumnal equinox on September 22nd. And this time of the year, when we get around the autumnal equinox, either equinox actually, we can look out for enhanced aurorae. And that's because the Earth's magnetic field vectors are aligned such that the magnetic field is less able to fend off the solar blasts. And so more of the charged particles get through and trigger a bit more aurora activity around both equinoxes of the year. And for those of us that love dark skies or maybe doing imaging and need a dark sky, we talk about astronomical twilight. So astronomical twilight is the final remains of the day as the sun is getting deeper and deeper below the horizon. When the sun gets between 12 and 18 degrees below the horizon, we're in that astronomical twilight period. And the sky is as dark as it's going to get once the sun gets below 18 degrees. And so today, that's going to be starting at 9:19 p.m. And then the sky will begin to get bright again tomorrow morning at 5:10 a.m., which gives us nearly 8 hours of dark imaging time. But good news is that imaging time is actually growing in length by 4 minutes per day at this time of year. Now, next month, the astronomical twilight will arrive at 8:24 and at 5:47, and that gives us almost 9.5 hours of imaging time, although the rate it's increasing will be lower at that point. And that's to do with the balance between the day and the night and how during the winter months we have less day and more night, sort of that kind of thing. In terms of the moon, I've got some perigee-apogee dates here. In terms of the phases, we just had the new moon on Monday the 6th, and now we're heading towards first quarter next Monday, the 13th. First quarter moons always set around midnight, so they arise around noontime in the daytime, and you can see them in the afternoon as well as in the evening sky. Perfect for youngsters that want to look at the moon. We get the full moon, which will be the harvest moon on September 20th. That's because that full moon is occurring closest to that equinox. And then we get our last quarter moon on Tuesday, September 28th, and that generally opens up the dark sky observing window, which will last until a couple of nights past the next new moon on October 6th. So we're just finishing one period and we'll have another one at the end of the month. Anybody wants to participate in International Observe the Moon Night, that's October 16th. Now, a little bit about the harvest moon. So the harvest moon phenomenon happens because at this time of the year, the ecliptic is very shallow, and therefore so is the moon's orbit, which is this light line here. So that means is that as the moon is traveling along its orbit, it's actually doing a little bit more right to left motion than it is up to down motion, which normally the moon rises later each night because it's sort of traveling down and is delayed in rising. But at this time of the year, it's going more sideways than up down. And that means that over several nights, the moon tends to rise only about 20 minutes later each night. Here's a set of times surrounding this harvest moon time. You can see there's about 17, 18, 22-minute difference between each consecutive night. That means that if you have a regular schedule where you're walking the dog or you're coming home for work or school, you're basically going to maybe be noticing the moon there on a few different nights, consecutive nights, because it hasn't really moved on and moved out of the sky. Contrast that with the winter solstice full moon. They rise a full 62 minutes later each night. So it's completely the other end of the spectrum. And of course, those harvest moons lingering in the sky were also giving the farmers in the field the opportunity to work the fields later. So that's where the harvest moon came from. So here's a calendar of the month, starting with tonight's meeting here on the 8th and running to the next meeting on the 6th of October. And you can see we're just ending a dark sky period in a day or two. And then on Friday, you can be on the lookout for the crescent moon in the western sky and the earth shine. That's the sunlight reflecting off the shiny earth and partially illuminating the dark hemisphere of the moon, the unlit portion. You might get that on the 9th, 10th, 11th, in that range. Then we get into the period of the week where we've got the moon, the first quarter moon in the evening sky. So that's a great time to look at this Lunar X, which I'm going to talk about, the Straight Wall and the Alps and Apennine Mountains, which are great features to see even naked eye or with binoculars. And then towards later in that week, we've got the golden handle effect. There's that harvest moon on the 20th. That's a great time to look at lunar ray systems. So the rays that are the ejecta emanating out of craters like Tycho and Proclus and Copernicus. So those are great ones. And then here we go into the dark sky observing. So speaking of the Lunar X happens half a dozen times or so a year when the longitude of the sunlight arriving around first quarter is aligned enough that the sunlight illuminates preferentially the craters, the rims of several craters, Lacaille, Blanchinus, Purbach. And you can see that here's a photograph taken by Diaz-Bobillo showing the Lunar X feature. Now, the Lunar X will build up over an hour and a half or 2 hours, peak in intensity, and then as the sun rises higher, it starts to fill the light in around it, so that the feature will then dissipate over the following 90 minutes or 2 hours. So you've got roughly 3 or 4 hours to get a chance to see it. Now, the next one's happening on Monday the 13th. It's going to start forming around 5 p.m. Eastern time, which would be still quite bright daylight for those of us in Toronto. But if you've got a polarized filter or even a pair of 3D glasses from the movies that have polarized lenses in them, you can use those to darken the sky and enhance the contrast on the moon. So you could even take a look before it gets too dark. The peak of the X will happen around 7 p.m. It'll start getting a little bit dark by then, and then it'll last till about 9 o'clock. So sky will be getting dark by about that time. And while you're at it, there's a lunar V that sits. So there's the Lunar X. It's about 24 degrees south of the moon's equator, right on the terminator here. Then you've got the lunar V, which is north of the lunar equator. And then I see an L. There's some people report seeing an L down by the South Pole. And there's kind of a backwards E that's visible in some circumstances. So there you've got a crater for the O, and you've got love plus the X. So give that a go. One great way of testing how the moon is going to look at any particular hour on any particular day of the year is to use the NASA Dialem page. So here's the URL. Just click on that, and you'll see a little interface that shows you a place to plug in the date, plug in the hour in universal time. So for us in Toronto, if you wanted to see how the moon will look at 9 p.m., then you're going to want to put in tomorrow's date at 0100. So that's the 4-hour difference to the universal time. And then you can actually plug in different hours and see how the Lunar X forms or doesn't, or increases and decreases in intensity, just to confirm and match up with what you're seeing. So that's a great tool. In terms of what the planets are up to, here's a kind of a broad view of the horizon from southwest to southeast. Tonight's sky at around 8 o'clock. And here we've got, if you can see it too well, but the planet Mercury is just hovering above the western horizon. This is Mercury's been up for another week or 10 days or so, and it's been a really poor apparition for us in the northern hemisphere. Folks in the southern hemisphere are getting their best view of Mercury for the year, where their ecliptic is almost vertical, so the Mercury is shining nicely in a dark sky. But for us, it's just sort of lurking above the the west-southwestern horizon. And best chance to see it will come somewhere around the 13th, 14th of the month when it'll be at its greatest angle from the sun. And then it'll start dropping back towards the sun again. And that'll end our view of it. Venus is hanging out too in the west. You can't have missed it. It's extremely bright. It's still fairly low in the sky, so you may need to walk around, step around a neighbor's house or building or some trees, but it's there. And it sets fairly early in the evening. If you do put your telescope on Venus, of course, make sure the sun has completely disappeared, but you should see a waning gibbous phase. So it's sort of a football shape right now in your telescope. And its disk is growing a little bit bigger every day because Venus is starting to move towards the Earth and in between the sun and the Earth. That's why its phase is waning and its disk is growing. Mars is not visible right now. It's too close to the sun. Good news, though, is it reaches solar conjunction on October 7th, 8th, and that sets the stage for next year's return to Mars at opposition, a great big Mars in the sky for next year, next December. Now, Jupiter and Saturn are over here in the southeastern sky. They're about as high as Venus is, around 8 o'clock. So one is rising, one is setting. Jupiter is very bright, magnitude minus 2.8. Now, because of the low height, the ecliptic at this time of the year, Jupiter and Saturn don't get more than about a third of the way up the sky. So it's not the greatest for telescope viewing, but do your best. And by the time we get into late evening, they're at their highest point, which will be your clearest views of them. In Jupiter, you can see the red spot every second or third night, and there are quite a few single shadow transits. Those are the 4 Galilean moons of Jupiter cast their shadows on Jupiter's disk, and you can see, whereas you can't see the moons very easily in an amateur telescope, you can certainly see the dark black shadows if your seeing conditions are good. Saturn is about 16 times fainter than Jupiter, and it's sitting about 1.5 fist diameters to the west of Saturn and kind of leading it across the sky every night. So both of those objects are visible all evening long and for a couple of hours after midnight, certainly. What's neat about Saturn is that its rings are gradually closing every year. So at this year's visibility, the globe of the planet is now extending slightly past the ring plane. So you're getting that classic Saturn picture that everybody would doodle if they were sketching it. Uranus and Neptune are around. So Uranus rises in late evening in southern Aries, so it's way over here to the left of the scene, and best viewed around the middle of the night or in the hours of the morning. But it'll eventually migrate itself into our evening sky in the next month or two. But Neptune is not far from Jupiter, so if you kind of take the Jupiter-Saturn distance and extend it further to the east, you'll run into where Neptune is. So it's basically an all-night target. It's going to reach opposition in a few days. I think it's around September 14th or so. And opposition is the best time to see Neptune when it's at its biggest and brightest, albeit still dim and small, but it's its best conditions that you can expect. And that's a great time to look for Neptune's big moon Triton, it's dim, but it's the opposition times are your best opportunities for seeing it when it's at its peak in brightness. One cool thing is that Neptune itself will be passing very close, telescope close, to a magnitude 6.25 star on the evenings around September 23rd. So you should be able to find that star very easily, possibly naked eye, but certainly with binoculars, and then look for the Neptune's little blue dot just below it. It'll start off to the lower southeast, so the lower left, and then it'll be below the star, and then a little bit to the lower right as that goes. And we have the asteroid Pallas, which is reaching opposition itself on September 11th. So that's this weekend, and it'll be at its brightest for the year, albeit not bright, but magnitude 8.5, and it's in western Pisces. So here are some of those Jupiter shadow transits I was talking about. We've got Io shadow on the September 11th, which is Saturday night in late evening. We've got Europa shadow with the Great Red Spot on Sunday night in late evening as well. And then we've got the scene that I've got underlaid here. This is actually Jupiter, the Great Red Spot, and Callisto shadow, with Callisto off to the right here. And they're going to be on September 17th from dusk. So the shadow will already be transiting at dusk till about 11 p.m. Now, in some apps, around 8 o'clock, it shows that the shadow is actually in the center of the Great Red Spot. There'll be a little bit further to the left of the scene, but it looks like a pupil in the eye of the red spot. So Stellarium shows it that way. Sky Safari disagrees with it a little bit. So I can't be sure which is correct, but your mileage may vary, but it's worth checking it out. And then we've got a few Io shadow transits. Io shadow is a bit smaller than the others, so it's not as visible or not as apparent. But you've got them on the 20th, 27th, and October 4th. If you want to see satellite passes right now, the ISS, the International Space Station, is flying over the Toronto in the morning. That's going to end on September 13th. It's going to transition into evening passes the following night. So September 14th and on, you'll see the ISS flying overhead in the evening between about 8 and 10 p.m. Here are a couple of the brighter ones that I've noted on the 19th and October 4th. If you want to know when it's flying over precisely on any given night, or if you don't live in Toronto and you want to check your own location, navigate over to heavens-above.com. You'll see a place to enter your location in the upper right corner of the website. And you can then get a list of when the ISS or any other satellites really are passing. Or you could grab a smartphone or tablet app. There are a number of good ones out there. And then I also report them in my astronomy skylights every week for people that want to read the skylights or get the email that I send out. I found a nice asteroidal occultation to be on the lookout for. So this is one on September 22nd, although it's 4:24 a.m., so it's not for the faint of heart. You won't have to be dedicated to get up and watch it. But this is asteroid Sonnenberger, which is a very faint magnitude 16.9. But not to worry, the star that it will occult is actually relatively bright, magnitude 10.1. It's a star in Gemini. At the occultation, it's predicted to dip the brightness of the star by 6.8 magnitudes for about 2 seconds. And they sit about 67 degrees up in the sky, nice and healthy altitude in the sky. And the track, the center of the predicted track goes right through Mount Forest, Mono, East Gwillimbury, and out to Peterborough. And then the standard deviation lines, which are the blue lines, extend up to Georgina and down into Vaughan and Markham areas. So anybody in the zone who could monitor the asteroid occultation will help scientists determine the shape of the asteroid. All right, let's switch over to Stellarium. So here I've got a view of the sky tonight at 8 p.m. So this is there's that Mercury tucked just above the horizon, and we've got the moon, crescent moon, freshly new after this week's new moon, sitting just above it. Tomorrow night, we've got the moon shining here near Venus, so that'll be a kind of a neat photo opportunity. And what I want to do is just bring up Vesta here. So the asteroid Vesta is actually going to be in there as well. Now, Vesta's not really bright enough, magnitude 7.7, to readily see from where we are. But if you're tuning in from a place at a more southerly latitude, then you'll see Venus, the moon, and Vesta in a darker sky. Or you could wait until a bit later, they'll be low. So that's something that you can take a look for. If we kind of watch the moon track the sky over the next number of nights, it's going to pass through Libra. It's going to make a nice picturesque view above the reddish star Antares on the 12th. If we keep going past the teapot as it's waxing fuller, by the time we get to around the 15th or so, you'll be able to look out for the straight wall down here in the lower part of the moon. And then you can check out those mountains that I talked about curving around the Sea of Showers at the top part of the moon. Right around the time of the month where the terminator just gets a little bit west of them. And as we head a little bit further along, a couple of nights later, the moon will be full enough that we can pick up that golden handle, that little handle effect that's on the edge of the Marian beam there. All right. Now, heading on a little bit further, we get the moon is going to pop past Neptune. Now, the moon does Neptune's no favor, so it's not a great time to be chasing after Neptune when the full moon is hanging out nearby. But it does give you an idea where Neptune is in the sky, so you can come back later and check that out. And we've got that full moon on the 20th. One of the neat things that's going to happen at this full moon is that we've got lunar libration. So the moon actually tilts, nods its head up and down and tilts left and right as it goes around the Earth. And that phenomenon we call libration. And at this full moon, the moon will actually be tipped a little down and a little bit to the west, which allows us to see features that are normally out of sight in the northeastern edge of the moon. So you can look for things like this dark stain of Mare Smithii. There's the Mare Marginis, which is up here. We've got the crater Hubble tucked in here, and a few things like that you can chase down when the moon is at that geometry for us. And just to finish up, a couple more days on, we get the moon jumping past Uranus. And then on the 25th, got this nice photo opportunity or binocular opportunity to head out late in the evening and look for the moon sitting below the Pleiades and above the Hyades of Taurus. So that'll be a cool one to look for. All right, let's switch over now and talk a bit about some observing. Let's move out here, some double stars. I'm going to head back. So the best time to look at things is when they're highest in the sky. Oops, let me just go to Altair here. So what I've got here is the green line, the up-down line. This is the meridian. So this is the north-south line from the southern horizon over, arcing overhead, where the zenith is here, and then it drops down in the northern sky. When objects are near the meridian, they're at their highest, especially the ones that have southerly declinations. So the best time for us to see objects in Capricorn or in Sagittarius is when they're crossing the meridian, they're highest. Otherwise, objects that are more northerly or more circumpolar, they tend to be high in the sky all the time. And essentially what you want to try to do is look at objects that are more than about 45 degrees above the horizon. So if I click on a star in Cygnus, you can see that we're reporting in Stellarium that we're looking through one air mass, which means that we've got one layer of thickness of the Earth's atmosphere above us, straight overhead. And as we look at objects that are a little bit lower in the sky, the air mass number goes up slowly at first, and then eventually it goes up quite a bit more. As by the time I get down to Altair, I'm looking at 22% more air. By the time I get to Capricorn, I'm looking at nearly double the amount of air. So anything I'm looking at has to traverse more than twice the amount of air as anything I'm looking at straight up. So that's a great reason to focus your efforts on things that are high up in the sky. In terms of variable stars, as I mentioned, there's a couple of neat ones that you can keep an eye out for. So in Aquila, the star that's at the elbow of the lower wing of Aquila is Almazan II or Eta Aquilae. This is a variable star that actually varies by one magnitude over about 7 days. And when it's at its brightest, it's equal to the tail star of Aquila. And when it's at its faintest, it's equal to the Iota Aquilae, which is kind of tucked in between here. So you could look at these three in a row and you can see, is the star more like this one or is it more like that? We head on up to Lyra, top of the sky. We've got our parallelogram in Lyra. The star Sheliak is also a variable star, so it varies by about a magnitude from 3.3 to 4.4 in 13 days. When it's at its brightest, it's equal to Siliphat, the other corner. And when it's at its faintest, it's equal to Delta. So again, you can just glance and see which phase or which cycle is it at right now. And finally, to head on up to Cepheus, which is in the northern sky, we've got the Cepheid variable star Delta. Cepheid variable star Delta doubles in brightness about every 5 hours and 5 days and 9 hours. And when it's at its brightest, it's the same as Zeta. And when it's at its faintest, it's the same as Epsilon. So you can just look at this trio and see where it is in the cycle. Now, you may have seen in your Rask Observer's Handbook a reference to the minima of Algol. So Algol, the star Algol in Perseus, is an eclipsing binary system. And that means that every 2 days and 21 hours or so, a companion star blocks the light from the system and produces a drop in brightness that lasts a total of 10 hours. So it takes 5 hours to decrease and 5 hours to recover. And when it's at its normal brightness, Algol is the same as Almach, but when it's at its dim period, it's the same as Rho or Gorgonea tertia, Rho Persei. So on the night of September 15th at 9:40 p.m., Algol will be at its minimum, and then 5 hours later, it'll be climbing the sky, nearly well overhead, and it'll have returned to its normal brightness. So that's one that you can check out. And again, you can just look through the Observer's Handbook and find them. The trick is to find one that's either going to end at a decent time or begin at a decent time so that you're not kind of waiting all night for the change to happen. So my target zone for the month, I think, is certainly going to be Cygnus. So let's head on over to Cygnus and look at some of the best things to look at in Cygnus. Let's run this back into the evening time. About 9 o'clock is best. Get rid of my meridian. So Cygnus is just loaded with all kinds of interesting things because it's traversing the Milky Way. You can see the dark lanes of the Milky Way run right along the long axis of the constellation. Let's start out with some really interesting things. Well, obviously, we've got Albireo as a favorite. So Albireo is the nose of the swan. In a telescope, Albireo will actually grow into a split into a pair of stars, one golden and one blue, or yellow and blue, fairly without a lot of magnification. So that's really a crowd pleaser. There are lots of other really interesting ones here. Let me just bring up some binocular circles so you can get a sense of the scale of things. So I'm just going to bring this up to about 6 degrees. If you look at the area above Deneb and Saturn, you can see that there's a pair of bright stars. This is Omicron Cygni. So those would be visible with unaided eyes or binoculars. If you're looking at them, see if you can see that little star 30 Cygni tucked in close. Maybe you can pick that out if you've got good eyesight. Down here below that, we've got another fairly wide, easy pair of binary star, double star. We've got Omega. Omega 1 is also known as Rukba, and Omega 2 is this W2 Cygni star. Then we've got a star U Cygni. Let's bring that U Cygni up here. So U Cygni is back up near Omicron again. U Cygni consists of kind of a white or a pale star, maybe a bluish star, and a very reddish star. This is a carbon star. And U Cygni is part of the RASC double star observing program. So for that, you'll need a telescope, but it's not that difficult to split in a backyard telescope. So check that one out. Then we've got Bessel star, 61 Cygni. Let's see if I can find 61 Cygni here. I'll do that with the search function. There we go. So 61 Cygni is over here below Deneb. And this is also a fairly easy split in a telescope, and it's also part of the RASC double star program. And finally, one last one you can check out is the upper joint in the wing of Cygnus. And this is Phawaris or Delta Cygni. And this one needs more power to split. You need to really zoom in and magnify this one to split. Phawaris is a neat star that will one day be Polaris for Earth. It'll one day be marking the North Celestial Pole. So that's kind of cool. All right, what about deep sky objects? So a couple of interesting things in here. The star Eta. So if you're looking along the neck of Cygnus between Saturn and Albireo, you're going to notice a star named Eta, kind of halfway down. And if you put your binoculars, your telescope on Eta, you can find this star designated V1357 Cygni. And V1357 Cygni is a blue giant star. This is the star that is the companion to the Cygnus X1 black hole. So back in 1971, Tom Bolton used the David Dunlap Observatory telescope to take the spectrum of this star, and he determined that something invisible and massive was tugging the star around and causing the spectrum of the star to oscillate blue shift, red shift. And it coincided with an X-ray source, and so that's the first confirmed black hole done by the David Dunlap Observatory. While you're in the neighborhood, you could check out this really nice emission nebula sitting close by. I think this is Sharpless 2-101, I think it's called. So that's something you can check out. In terms of other deep sky objects, we've also got, let's talk about asterisms for a second. So asterisms don't mind the moon, don't mind a little moonlight. So if it's not quite a dark night and you want to look at something with star patterns, you can check out this little asterism called the fairy ring, or Chappell's arc, I believe it's called. Yeah. And this consists of a set of double stars. You've got double, 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 another double down here, another double down there. And there's even a double in the middle, forming a nice little ring. This measures about 21 arc minutes across. So not quite as big as the moon, but it's be a cool little sight. We've got an asterism called the red-necked emu. And this is located So the little fairy ring is up here. The red-necked emu is down here. And this consists of a couple of sort of arcing bright stars in 3 arcs that are kind of centered on one star, kind of like legs and a neck of an emu. But my favorite one is this little Orion one, which is inside the North America Nebula. Can you see the Orion? There's the 3 stars in the belt. Here's a red Betelgeuse. Here's Bellatrix. Here's sort of Rigel and Safe, but traded places. So it makes a nice little asterism to check out when you're looking at the North America Nebula. Of course, the North American Nebula itself is a terrific target for binoculars if you're in a very dark sky, or if you've got an oxygen 3 or UHC filter, you can use that to enhance the brightness of the glowing gas. The gas complexes are all really one large complex that's being broken up by opaque dust. And it's actually split this into this North America shaped glowing cloud. And then the second cloud, which is called the Pelican Nebula, which is sitting just off to the side here with this dark dust dividing them. Fun to look for the star in the center that looks like Orlando in Florida. And you've also got a little darker circular feature called the bird's nest. And there are some little open clusters that are inside the North American Nebula. So if your skies don't allow you to really see the nebula very much, you can still look for some of the star clusters inside as well. In terms of Messier objects inside Cygnus, we've got 2 of them. We've got Messier 39, which is an open cluster. And then we've got the water cooling tower cluster, Messier 29. This is the one that actually has 2 rows of 6 stars in a sort of a diverging pattern. It's really interesting in a backyard telescope. Only 2 Messier objects, but there are lots of finest NGC objects. You've got things like the Foxhead cluster, which is sitting up here, the blinking planetary nebula. So that's the one where you want to use averted vision to make the envelope around the central white dwarf star brighten and dim as you use averted vision and regular vision. So that's sitting up there by the upper wing, not far from our friend Phoaris. We've got the Crescent Nebula over here in the neck. The Crescent Nebula's got the concentrated arc of glowing gas. Then you've got a Wolf-Rayet star that's illuminating the gas. It's also a great imaging target for anybody wanting to get something there. And finally, over on the edge of the boundary with Cepheus, don't forget that you've got the beautiful Fireworks Galaxy. Is technically part of Cygnus, sort of shared between the 2 constellations. This galaxy is about 1/3 the diameter of the moon, so it's about 12 by 11 arc minutes across. It's fairly dim because it's face on to us, but if you've got a really dark sky, it's spectacular and big in a telescope. So I'm going to stop there. I'll take any questions.
Thank you so much, Chris. Let's go to questions. Blake, are there any?
Yeah, we have a few. I had one for you, Chris. I don't know if you had a look. Are there any interesting comets going on over the next month?
I did take a look, and I didn't see anything that I thought were worth chasing. There are always a few magnitude 10, 11 comets around, but not something that I thought was fit for some of our beginner audience. We have a few that are passing solar perihelion that may brighten up November, December timeframe. So stay tuned.
Okay, thank you. Ron asked if there are large sunspots aiming towards the Earth, can they produce aurora?
Oh, yes, absolutely. So that Solar Dynamics Observatory that I showed the picture of, its job is to keep an eye on the sun. And there are other satellites that do that as well, to watch the side of the sun we can't see, because they are a potential source of coronal mass ejections and plasma blasts that can interfere with our communication satellites. It could potentially endanger our astronauts in the space station. So yeah, we are getting a little more flare activity in concert with the increased sunspot activity.
Okay, and it looks like the last question is from Betty. She asked, what is the typical duration for a sunspot?
Oh, it can actually vary. It depends on how strong it is in the first place. I think there have certainly been instances where a spot has persisted all the way around the rear of the sun and return to view again, so a month later. But I think more often during our quiescent period, we were seeing sunspots kind of pop up now and again and then fade in a few days. So it's really variable. So it's actually we're checking into spaceweather.com now and again just to see what's happening, and you'll get a sense.
Okay, thanks for that. And I don't see any more questions, so that's it for me.
Terrific.
Yep. Thanks again, Chris, for taking the time to gather all of this data and then presenting it to us.